We're going to continue looking at reaction dynamics. We're still in the same section, 5.4, and we took a look at heat with exothermic and endothermic reactions. Just as a reminder, since we have this here, exo means exit, heat's coming out, and endothermic, endo means in, heat's going in. Exothermic reactions get hotter, endothermic reactions get colder. So imagine that you have a snake. And when is that snake going to be very active? The snake's going to be more active during the warmer parts of the year, or if you have some type of heating lamp, if you're keeping that snake at home. But out in the wild, those snakes, well, even in the cage, they're cold-blooded, which means that they are going to be regulated by the outside temperature, meaning if it's hot, their internal temperature will be warm. If it's cold, their internal temperature is going to be cold. They can't regulate their temperature like we can regulate our temperature. So we have the same snake, but in warmer temperatures, they're more active. Well, the reason why they're more active is because biologically, their molecules and their chemicals can react more quickly. If a snake is cold and they eat something, they don't even have enough energy to actually digest what they've just eaten. They have to be in a warm environment. That's because their molecules are not working at the optimal temperature. So that's what we're going to be taking a look at, and we're going to be taking a look at what are called reaction rates. And reaction rates, another way of saying this is the speed of the reaction. So the speed of the reactions when it's warm is very, very fast inside the snake. When it's cold, those reactions are very, very, very slow. So there's a couple of factors that will affect the reaction rates. We talk about this in detail in chemistry as well. And the first one is temperature. If I increase the temperature, what happens is those molecules move faster. You increase the speed at which the molecules move. So you increase the speed of movement. Okay, it's like a solid versus a liquid and a gas. A solid is a low temperature and the particles are vibrating. At a higher temperature, they're a liquid and they're flowing. When they're a gas, they've got a lot of energy. They're moving extremely fast. So if you increase the temperature, you increase the speed of the movement. What that does is it causes it to go faster. It's a faster reaction. So if you have a faster reaction, what does that do to your reaction time? This is could be confusing for some. It causes the time to go down. It decreases the time for something to react. Going back to the snake. Okay, you increase the temperature, the molecules are moving faster, we have faster reactions. It decreases the amount of time that is needed for that snake to digest its own food. If we look at the reverse of this, if we decrease the temperature, all of that reverses. We are going to decrease the speed of the movement. That means my reactions are going to be slower. My reactions are slower, it's going to take longer for them to take place. We're going to increase the amount of time. So that is with reference to temperature. Now, one thing we also take a look at in chemistry is the size of the particle. Size of the particles. Now imagine we have a piece of something and we're trying to dissolve, and it's this big. Where is the dissolving, or where is the reaction going to take place? The reaction is going to take place on the surface, right here. We can't have reactions taking place on the inside because things are coming from the outside to contact this surface, and that's where the chemical reaction is going to take place. So chemical reactions take place on the surface. Chemical reactions take place on the surface. of this material right here. Well, imagine that I take this now and I break it into smaller pieces. Okay, we're going to break it or cut it into smaller pieces. So now I have this, 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 and this. And look what's done. All these pieces on the inside are now exposed. If the chemical reactions take place on the surface, we've now increased the surface. So what we've done here is we've increased the surface for the reactions to take place. All of these pieces used to be hiding on the inside, and now they're exposed. We've increased the surface. There's more surface. So if you increase the surface, what's happened to the size of my particles? We've actually made smaller particles. So when you have smaller particles, smaller particles is then going to increase the surface. And if it's going to increase the surface, what's that going to do to the reaction rate? Is it going to make it go faster or is it going to make it go slower? It's going to make that reaction go faster. We increase the speed of the reaction. So it's going to go faster. If we have these larger particles, over here, what's happened to the surface? Well, a lot of the surface is hiding on the inside, so we actually have less surface. We've decreased the surface. And if you decrease the surface, that means your reaction is going to go slower. We're going to decrease the speed, and it's going to go slower. And that's what we're going to be examining in the lab, and we're going to be using Alka-Seltzer for this.